If you touch something that is very hot, you'll get burnt. This is because of conduction. The heat is conducted by a sort of domino effect from molecule to molecule, or from atom to atom, along the hot object and into your fingers. That's one kind of heat transfer. But if you hold your other hand above the same hot object, you will also get burnt. This is because of convection. The hot object causes the molecules of air above it to speed up. The hot air expands and becomes less dense, and is therefore conveyed upwards. That's a second kind of heat transfer. Are these the only two ways that heat can be transferred? Then why are you sitting under that beach umbrella? Because the sun's too hot? But how can the sun transfer heat to you? You're not touching it, so there can't be any conduction, can there? And since most of the space between you and the sun is just that, space, except for the thin layer of air formed by the Earth's atmosphere, there can't be any convection either, can there? Because once you get beyond our atmosphere, there's almost nothing out there to do the convecting. But the sun still feels hot. Amazing. How is that possible? Is there a third kind of heat transfer which allows heat to move through empty space? Yes, there is. The sun sends out waves of heat energy in all directions. Each of them is rather like the spoke of a wheel, and this is exactly what scientists call them. Only they use the Latin word for spoke, which is radius, from which they get the word radiation, the name given to this third kind of heat transfer. So it's by means of radiation waves that the sun can transfer its heat energy to you and make your molecules go faster and therefore make you hotter.
But what about convection? Convection occurs in fluids. So let's start off and notice I've got a candle and I've got a couple of stove pipes here. Let's take a look. If I light the candle, I put it inside. Put the stove pipes on. Take a piece of paper and burn it. So because I need a smoke source. And notice that the smoke is being drawn down the right-hand tube and is going to come up the left-hand tube. Why? Well, by convection, which is a difference of densities. The air above this candle is less dense because it's hotter, and so it rises, just like bubbles in water, and which must draw down the other side. Again, if you're moving matter here, then it has to create a vacuum which pulls some air in from somewhere else. Put that out by using the piece of metal. Now to show that one more way. So I'm going to put that in the pieces. Okay, we do this a different way. If I take this tube, which has got water in it, and I start a Bunsen burner, use the other way here, I'll do good safety here and put on, someone can, there, that's good. Since I have the Bunsen burner on, well, we'll do this another time later on. Okay. Start with yellow dye. You'll notice the dye is starting to move this direction. Why? Because the heat is rising on this side, pushing it around the tube. Well, I can turn the tube and cause the convection to go the other direction. Heating this side, which will cause less dense water to rise, which will move the convection the other, oh, notice it stopped at the bottom, and now it's starting to drive it the other direction. Okay, now I can change from the yellow dye and change to a darker dye so that we can see it on top of it. That way I don't have to keep changing the water. We'll know which way is hotter by the way it begins to move. It's not really going anywhere, but we'll drive it that direction towards your left. I will turn it as soon as it starts to move, and we will drive it the other direction. Not yet. There it is, starting to mix. There it goes. Convection. Less dense liquids or fluids rise, causing convection. And notice that it is turning this direction. Okay?